The second you walk into this forest, a smell hits you, sharp, sour, like a dumpster packed with rotting fish. There's no dumpster, just a colony of yellow crazy ants. They got their name from the frantic, erratic way they run. The ants themselves don't smell at all. That stench belongs to their victims. Since the 1990s, these ants have slaughtered roughly 40 million of Christmas Island's iconic red crabs, leaving cracked shells where millions once marched to the sea. Now, scientists are fighting back with the last thing you'd expect: a few million wasps. The Great Crab Migration. For a few weeks each year, Christmas Island stops looking like a normal island and starts looking like the crabs own it. They pour out of the forest and move across roads, gardens, rocks, beaches, and front yards. They gather in thick red crowds until whole parts of the island seem to be crawling. It can look like a disaster at first, but it is not. This is exactly what the island is waiting for. Christmas Island sits far out in the Indian Ocean as a small Australian territory, remote enough that life there developed in strange and special ways. And nothing shows that better than the red crabs. The island has only about 1,200 human residents, but during migration season, up to 100 million crabs can move from the forest toward the shore. So yes, the humans are badly outnumbered. During those weeks, people are not really in charge. They are traffic helpers for crabs. These red crabs, known as Gecarchoidea natalis, spend most of the year hidden in the island's moist rainforest. They live around burrows and shady places where their bodies will not dry out. They need moisture badly. When the dry season comes, they can plug the entrances of their burrows with leaves and stay tucked away for months, waiting for the air to change. Then the first heavy rain arrives. That is the signal. The forest floor wakes up. Crabs that have been hidden underground begin to move. Males usually start first, leaving their burrows and heading toward the ocean. Females join along the way. By the time the larger males reach the coast, they are worn out from the trip. They dip into the sea to regain moisture, then move onto the lower shore terraces and dig burrows. There, the females arrive and mate in or near those burrows. After that, the males head back inland, but the females stay behind. Inside the damp burrows, each female produces eggs within about 3 days. And one female can carry up to 100,000 eggs. Then, before sunrise, when the tide is right, the females crowd near the water. They move down to the edge of the sea and release the eggs. The moment those eggs touch salt water, they hatch. Tiny larvae drift out into the ocean, beginning the most dangerous part of the whole cycle. Most of them never return. Fish eat them, manta rays eat them, whale sharks arrive for the feast too. For about a month, the young crabs are at the mercy of the sea. In many years, almost none survive in large numbers. But once or twice a decade, something goes right. A huge wave of baby crabs makes it back to shore, and the island gets its next generation. That is when the people of Christmas Island get busy again. Roads can close during the migration. Barriers are set up to steer the crabs away from danger. Crab bridges help them cross above traffic. Residents use rakes to clear paths so they can drive without crushing them. And when the tiny baby crabs return from the sea, they are too small and fragile for rakes, so people use leaf blowers to gently move them off the roads. These crabs are not just a strange tourist attraction. They are part of how the island works. For most of the year, they eat fallen leaves, fruits, flowers, and small seedlings. They clean the forest floor. They turn the soil as they dig and move. Their droppings feed the ground. They help keep the rainforest open, balanced, and alive. Without them, the forest does not work the same way. So when something started killing them, it was not just wiping out crabs. It was tearing through the island's cleanup crew, soil crew, and forest crew all at once. And the thing that nearly broke this ancient migration was an ant so small that most people would never even notice it. How crazy ants became a nightmare. A red crab looks like it should have the advantage. It has a hard shell, strong legs, and claws built for pushing through the forest floor. Next to it, a yellow crazy ant looks almost ridiculous. Tiny body, thin legs, easy to miss. The kind of insect most people would brush away without thinking twice. But on Christmas Island, size did not matter. One ant is almost nothing. A super colony is a disaster with legs. The yellow crazy ant is officially called Anoplolepis gracilis, but its nickname tells you what people notice first. It moves in a wild, restless way, darting around instead of marching in neat lines. That is where the crazy name comes from. Not because the ants are actually insane, though after what they did to the island, you can understand why people might think that. These ants are considered one of the worst invasive species on Earth. Their true original home is still not known for sure, but they have spread across many warm, wet parts of the world. And on Christmas Island, they were never supposed to be there. No one knows the exact crate, ship, plant pot, or cargo package that brought them in. But sometime in the first half of the 20th century, yellow crazy ants reached Christmas Island by accident through human transport. And once the ants landed, Christmas Island had a serious problem. The island was warm, it was humid, it had forest cover, it had food, and it had no natural system ready to push the ants back. In their new home, they did not stay as small, scattered nests. They started joining together into massive connected colonies. It was nest after nest after nest, linked across the forest like one crawling empire. These super colonies can cover huge areas and hold billions of ants, and the red crabs were walking straight into it. A crab could leave its burrow, cross the wrong patch of forest, and enter ant territory without knowing it. The ants would rush out in huge numbers. They did not need teeth big enough to crack the crab's shell. They had something worse. Yellow crazy ants defend themselves by spraying formic acid. Formic acid is one of the strongest acids made in nature, and these ants use it like a weapon. When a crab disturbs them, they spray. They aim for the crab's eyes. They hit the soft joints in its legs. They attack the weak places that the shell cannot protect. The crab starts to lose control. It cannot move properly. It cannot see properly. It tries to get away, but now more ants are coming. More acid lands on its body. The crab gets weaker. Its legs fail. Its direction is gone. Then it is over. At their worst, these ants can crowd the ground with about 830 workers in a single square yard. When their colonies get thick enough, their acid can wipe out entire local groups of red crabs. Since the late 1990s, yellow crazy ants have killed tens of millions of land crabs on Christmas Island. Think about that for a second. Tens of millions. Not because the ants were bigger, not because they were stronger one-on-one, but because they attacked as a crowd, with acid, again and again, until the crabs could not survive in places where they had lived for ages. And once the ants took over an area, they did not just pass through, they occupied it. The forest floor became their ground. The crabs that had once moved freely through those places were pushed out, killed, or trapped in a shrinking world. So people fought back the only way they could at first: poison bait. For years, that was the main weapon against the yellow crazy ants. Rangers had to go into areas where the super colonies were thickest and place bait where the ants would find it. Sometimes the bait was delivered by hand. Sometimes it was dropped by helicopter. Either way, the goal was the same: get poison into the colony before the ants could kill more wildlife. In some places, the bait did knock the colonies back, but it did not end the war. Christmas Island is too large, too forested, and too full of hard-to-reach places. Even if one area was cleared, ants could move back in from remote parts of the island. A few years later, the same fight could start again. That made poison bait expensive. It took a lot of work. It was only temporary. And many local people did not like the idea of poison being used again and again on the island. Then researchers noticed something strange. The ant empire was not surviving on dead crabs alone. Its real power source was dripping from the trees. What made the ants so powerful? The yellow crazy ants were not building their empire alone. They had help from another invader, a tiny insect called the yellow lac-scale insect. It is a tiny sap-sucking bug that attaches to a plant and feeds like a living straw. It settles on a plant, pushes in, and drinks. That might sound harmless compared with an ant army attacking crabs, but this little bug was one of the reasons the ant colonies became so massive. As the scale insects fed from the trees, they released a sweet liquid called honeydew. To us, honeydew sounds almost cute. To the ants, it was fuel. Yellow crazy ants need sugar to keep their workers moving. They need it to feed a growing colony. They need it to hold together those huge connected nests that spread through the forest, and the yellow lac-scale insects were giving them a steady supply of it. The crazy ants climbed the trees, found the scale insects, and harvested the sweet liquid they produced. The more scale insects there were, the more sugar the ants had. The more sugar the ants had, the stronger the colony became. And the stronger the colony became, the harder it was for anything else on the island to survive near it. The scale insects fed the ants with honeydew. In return, the ants protected the scale insects from other insects that might eat them or disturb them. And because the ants protected them so well, the scale insects could build up in huge numbers. That meant even more honeydew, even more ant food, even more workers racing across the forest. It was a perfect deal for the invaders. But it was terrible for the island, because while the ants were getting stronger, the trees were also paying a price. The scale insects were feeding on plant sap. That means they were taking food from the trees while the trees were still alive. Then the honeydew they dropped onto leaves and branches helped mold grow over the surface. That mold could block leaves from getting the sunlight they need. So the trees were being drained, coated, and shaded at the same time. And when that keeps happening, the forest starts to suffer. Branch by branch, leaf by leaf, the damage builds. That is what made the invasion so dangerous. It was not just one creature causing trouble. It was two invaders helping each other. Together, they pushed the whole forest out of balance. That is why simply killing ants was not enough. Poison bait could knock back a super colony for a while, but if the ants still had their sugar supply hidden in the trees, they still had a way to rebuild. So the strategy changed. The target was no longer just the ants crawling on the ground. The real target was the food that kept them powerful. The plan was to make the ant empire go hungry. To do that, scientists needed something that could go after the yellow lac-scale insects. They needed a natural enemy that could attack the scale insects without turning into a new disaster for the island. Something small enough to find them, focused enough to stay on the right target, and strong enough to break the sugar deal that helped the ants take over. So the rescue plan began with a creature so small it could disappear on your fingertip. The tiny wasp sent to save the crabs. The creature chosen to challenge billions of ants was a wasp smaller than a sesame seed. Its name was Tacardioephagus somervilli, and it came from Malaysia. It was only about 2 millimeters long, which is about 0.08 inches. That is so tiny you could miss it even if it landed right in front of you. And this was not the kind of wasp that ruins a picnic. It does not sting, it does not build nests, it does not chase people, it does not attack pets, it does not damage plants, it does not go looking for trouble in your garden. In fact, most people could stand beside it and never know it was there. But for the yellow crazy ants, this tiny wasp had the power to break the whole system. Its target was the yellow lac-scale insect. The wasp would find a scale insect and lay eggs inside it. Those eggs would develop inside the insect and the scale insect would die. But bringing a new creature onto an island is not something anyone should take lightly. Islands are fragile. One bad decision can create a problem that lasts for generations. Australia already had famous examples of biological control going wrong. And the cane toad is the one almost everyone knows. It was brought in to help with pests, but it became a disaster of its own. So this could not be another careless release. The wasp had to be checked. It had to be tested. It had to pass through layers of approval before anyone could let it loose on Christmas Island. Before the wasps reached the forest, they had to survive a government risk analysis. The big question was not just whether the wasp could kill the scale insect. It was whether it would stay focused on that one target. If the wasp attacked other insects, it could become a new problem. If it harmed native wildlife, the cure could be worse than the disease. Christmas Island could not afford to trade one invader for another. On September 24, 2015, the final risk analysis was published for the proposed release of Tachardiophagus somervillei on Christmas Island. That report recommended release, and the project moved forward through the official approval process. Then, in December 2016, several hundred of the tiny wasps were brought from Malaysia to Christmas Island. That number sounds small compared with billions of ants, but the whole point was not to release one massive wave and hope for magic. The wasps had to be bred first. Their numbers had to grow under controlled conditions. Scientists had to give them the chance to multiply before sending them into the forest. After breeding, several thousand wasps were released at each of 4 monitoring sites between January and April 2017. Then they waited to see if the wasps could do their job. Could they find the scale insects? Could they lay eggs inside them? Could they survive in places where yellow crazy ants were guarding their sugar supply? Because the scale insects were not sitting there helplessly. They had bodyguards. What happened after the wasps arrived? The tiny wasps did not need to fight through the ants like soldiers. They only had to survive long enough to find the scale insects and do what they were built to do. And they did. The wasps established themselves at every site researchers were watching. They stayed alive. They found the right insects. They began reproducing. They became part of the forest. Then they started moving on their own. Without people carrying them, the wasps spread almost 1 mile from where they had been released. For an insect so tiny it can disappear on a fingertip, that is a serious move. They were finding new places, reaching new scale insects, and expanding the attack by themselves. At several monitored sites, parasitism rates of the yellow lax scale insect climbed to more than 50% within a few years of the wasp releases. That means the wasps were getting inside more and more of their target and killing it from within. In some parts of the forest, scale insect numbers dropped by over 90% compared to before the wasps were released. Trees that had once been covered in scale insects began to recover. New leaves started growing again on branches that had been dying. And once the scale insects collapsed, the ants lost their food source. In those same areas, yellow crazy ant activity dropped sharply. Surveys found major declines in worker numbers, and in some treated zones, the thick supercolonies broke apart completely. Instead of continuous carpets of ants, researchers began finding scattered, weaker groups that no longer dominated the forest floor. At the same time, the island's most famous animals were still making their huge return to the coast. By 2025, Christmas Island had up to 200 million red crabs, with up to 100 million expected to move from their forest burrows toward the shoreline during migration. But Christmas Island is not the only place where yellow crazy ants turned paradise into a battlefield. Another remote island proved they can be wiped out completely, and also showed why Christmas Island is a much harder fight. How another island beat the ants. Far out in the Pacific, Johnston Atoll faced the same enemy. Different ocean, different animals, same yellow crazy ants. The atoll sits about 824 miles southwest of Honolulu and is so protected that the public can only enter with special permission. It is home to coral reefs, hundreds of fish species, and one of the world's largest nesting populations of red-tailed tropic birds. It was an old military island, and for years nature had been reclaiming it. Birds nested on the land, plants pushed through abandoned concrete. Johnston Atoll was becoming a refuge again. Then the ants arrived. Yellow crazy ants were found there around 2010, and the danger was clear fast. On Christmas Island, the ants attacked red crabs. On Johnston Atoll, they threatened the seabirds. That sounds strange until you think about how seabirds live on remote islands. Many of them nest on the ground or in low plants because for a long time they did not need heavy defenses. No foxes were creeping through the bushes, no cats waiting at every nest, no army of acid-spraying insects covering the ground. Their eggs were low, their chicks were low. Their whole way of raising young depended on the island staying safe. Yellow crazy ants ruined that. A seabird chick cannot fight an ant swarm. It cannot fly away when it is still too young. It cannot understand what is happening. It can only sit in the nest while the ants move in. And these ants do not need to be large to do damage. They spray acid. They swarm soft eyes, skin, and open places. A chick can be injured, blinded, weakened, and left unable to survive. Adult birds can be harassed too, and nests can fail because the birds are forced into a fight they were never built to win. But Johnston Atoll also proved something else. The crazy ants can be beaten, not slowed down for a few weeks, not pushed back in one corner. Beaten. The fight lasted 11 years. The U.S. Fish and Wildlife Service led a project called the Crazy Ant Strike Team. Even the name sounds like a movie, but the work itself was not glamorous. It was long, hot, repetitive, and painfully careful. 20 teams took part over the years. Each team had 4 volunteers and 1 crew leader. Every 6 months, a new team came in and carried the work forward. That means people kept returning to this lonely island again and again, not to relax, not to film a travel vlog, but to search for ants. And searching for ants sounds simple until the target is tiny, fast, and hiding in weird places. The teams had to treat areas, check bait stations, search by hand, record what they found, and keep watching for any sign that the invader was still alive. Some of their methods were almost funny. To monitor ants, they used bait like tiny pieces of Spam. Not exactly high-tech alien equipment. Just meat, sugar, patience, and people waking up early enough to catch the ants when they were active. They placed bait on small tiles and in tubes across a grid, then came back later to count what showed up. But the work was deadly serious. The island was divided into survey areas, so the teams could check it again and again. One long-term survey used more than 300 monitoring points. Another treatment survey used nearly 900 stations. The wider island survey had more than 1,000 stations. This was not someone walking around and saying, "Looks fine to me." They were trying to prove the ants were gone, with enough care that nobody would have to guess. At one stage, the teams had to hand-search the infestation zone square by square. They checked any small place an ant colony could hide. Each area had to be searched over and over without a single yellow crazy ant turning up. Eradication is not just killing what you can see. It is proving that what you cannot see is not still hiding somewhere, waiting to start everything again. By January 2016, yellow crazy ants had stopped turning up in one of the main long-term surveys. But the team still did not just pack up and celebrate. They kept checking for years. By May 2021, that same survey had gone 48 straight rounds without finding yellow crazy ants. At another point, the final team checked more than 1,000 stations across the island and found 0 yellow crazy ants. Other ant species showed up, but the invader they were hunting did not. And then came one of the strangest parts of the whole operation. They brought in dogs. 2 trained conservation dogs, Solo and Guinness, were used to search for the smell of yellow crazy ants. These dogs had spent about a year training for that specific scent. They had to ignore other ants and focus on the yellow crazy ants only. They searched in December 2020. Their handlers guided them through the infestation area, working in the morning and again in the evening. Together, the dogs covered more than 110 miles of survey tracks and helped check more than 140 acres. They found no live yellow crazy ants. That gave the team even more confidence. Finally, in April 2021, after the last remaining search areas were cleared with no detections, eradication was declared. That victory is massive. It means yellow crazy ants are not invincible. They can be removed from an island if the conditions are right, if the area is controlled, and if people are willing to keep going long after the exciting part is over. But this is where Christmas Island becomes much harder. Johnston Atoll is remote, closed, controlled, and mostly uninhabited. There is no normal public traffic. There are no towns full of daily movement. There are fewer ways for the ants to hide in deep rainforest and fewer chances for people to accidentally spread them around. Christmas Island is different. It is much larger. It is forested. People live there. The terrain is thick, wet, and difficult. The ants can hide in places humans cannot easily reach. They can sit in remote patches of forest and come back after baiting clears another area. That is why poison bait helped but could not become the whole answer. So Christmas Island needed a stranger plan. And if those tiny wasps keep winning, the island's most famous march may keep turning the roads red for generations. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.